Hey everybody, welcome to my YouTube channel. I hope you find this video really interesting. Tell us what you think, Ron. I think it's going to be great. Okay, got it. Take care everybody. Enjoy. Hey everybody, hope everybody's doing good. So we're going to give you guys an update on where we are with this amplifier that we're building. I told you in the last episode that when I came back I would have everything pretty much done, and we're close. We're not exactly there yet, but we're real close. So let me show you where we are. So first of all, you'll notice that we have all of our components mounted. So here's our transformer, our output transformer, our electrolytic cap. There's 250s in here. Here's our 6V6s right here, right off of the output transformer where they're supposed to be. Here's our inverter tube, which is a 6AV6. And here's our preamp tube, which is a 12AX7. You'll also notice here in the front, I only have one pot. I don't have the 250K ohm pots I need for treble and bass. I'll get those tomorrow, so that's why they're not there. On the back, we have a line cord, we have a 1 amp fuse, we have an 8 ohm speaker jack, and we have our input. We're putting the input in the back on this amp. And the reason why we're doing that is so that we keep it in very close proximity to the 12AX7, our preamp tube. And of course we're going to have shields on these two tubes. So let's flip it over and I'll show you where we are. First thing you'll notice is I have these green wires flipping around here. This is our filaments. I haven't connected the filaments yet. They're connected to the tubes obviously, but I haven't connected them to the transformer yet because I'm going to be running a wire up through the top of this thing that's going to go to a blue light that actually sits behind the dial glass of the radio. But other than that, you'll see that we have everything pretty much populated. I've tried to do a very neat job, and you'll see here I'm trying something a little experimental on this one. I've installed these copper ground runners. I've got one going to a bolt here that's actually bolted to the chassis, coming across here to this side, all the way on the end. Let's pull this up a little bit. And then of course I have one here on the same thing. And I'm using those for all of my ground points. So I've decided I wanted to try this because it's a much neater build, first of all. It will make sure I have one ground point for the entire amplifier. Instead of putting separate ground connections into the chassis, everything is in one spot. We'll see if it makes it a much quieter amp. I think it will be. It could be a little overkill, honestly, but that's okay. So at least I have everything in one spot. And you can see I have all my connections soldered to this ground rail here. I have a few more I have to do, but for the most part, we're done with this amp. So you'll see I have my components all installed here. Here's my grid stoppers. I've got everything else in place, and I'll show you the schematic really quick. But in theory, here's our diodes, by the way. This is our rectifier right here. There's our electrolytic. And the only, like I said, the only thing I have left to do now is connect these filament leads. And I'll decide where I'm going to do that. I see a little opportunity here possibly, but we'll figure that out later. And then of course I have to install the tone pots here. And if I look at my schematic, everything that you see marked in green has been done. So the 6V6 tubes, everything is done. The 6AV6 tube, which is the inverter tube, everything is connected, no more to do there. Down here is our power section, right here, all complete. Here's our 12AX7. Everything is done except for two things. One is the input on pin 2. I haven't connected that yet. And the other one is on pin 7 on the other side of the tube, which goes to our tone stack and our volume stack. I don't have that done yet, obviously, because I'm waiting for the pots to come in. So once I get those pots in, I'll be able to wire this correctly. And I still have some room here on this board that I can use for these turrets to do some connections. So I think we'll be in really good shape, and then we'll be able to do some testing. I also installed our artificial center tap on the filament line. And what that really is basically it's a hum blocker, it's a hum reducer, whatever you want to call it. I call it an artificial center tap. Basically what you do is you take a 100 ohm resistor on each side of the 6.3 volt line and you put it to ground. And that prevents hum. You also want to twist your wires, obviously. But here they are right here. Here's one, and there's one underneath right here. Again, right up to our ground point, okay? And that goes to pin 2 and to pin 7 of the first output tube, right? It doesn't need to be on every tube, just the first one. So that will that'll do a good job there. So in theory, we're really going to be real close to being done here, right? When we get our pots in, we're finished. And I want you to be able to just see the build. Zoom in a little bit so you can see it. I paid very special attention to how I ran the wires. I have all the wires crossing like this. You never want wires running in parallel that are carrying different signals. So where you have to have wires cross, you do it like that. That's what I've done here. And I've used some solid core wire, mostly solid wire, but this way I can form it. And that will be a easier build for me. Here's our output right here. The wires shoot up here from the output transformer and connect right there. So there's our output, our 8 ohm. If I have to do a different configuration for an output, I can do that too. I have the additional taps on the output transformer that I can do. And we're going to, I think we're going to be in great shape. So that's really all there is to talk about. I do want to take a moment to mention what an inverter tube does. And I'm going to stop the video here. I'm going to set that up and then I'll show you. So let me do that and I'll be right back. Okay, I'm going to attempt to explain to you how a phase inverter works. Probably not something I can do in a minute, but I'm just going to do really high level. And if any of you think I missed the mark, just tell me. So basically, there's a couple of different kinds of amplifiers. One is an A, right? It's a single-ended amp. It's a Type A, one output tube, real simple, right? Signal comes in, goes out, you're done. But when you have two output tubes, it's an AB, and it's a push-pull. That's basically what it's called. And when you have a push-pull, you have to use a center tap output transformer just like we're using here. So here's our output transformer, and you'll see here we have our center tap. And what happens is when your signal comes in into the amp and goes out the plates of the 6v6 tubes, basically you have to look at this as a mirror, essentially. And what happens is if your signal comes in like this and your signal comes in like this and goes out like that, basically you're not in push-pull mode, you're in push mode. You're basically canceling each other out and you're not working together. That's what happens. So that's why you need an inverter tube. So there's a couple of rules here that that are crucial to understand how an inverter works. So we're going to draw the cathode on these output tubes. So the first rule is that when a signal comes in, and you, by the way, you're putting your signals into the grids, right? So when you put your signal into the grid, when you go out through the cathode, your signal stays the same. It doesn't change. But when you go out through the plate, it inverts. So in this case, it's going to be like this. So it inverts the signal. Same thing is true here, obviously. But if you put the signal through the cathode, it doesn't invert it. So if I have the same signal coming into these two tubes, how do I make sure that I have opposite ends, yin and yang, right? So the way you do that is with an inverter tube. So in this amp, we're using a 6AV6. And what we're doing, essentially, is we're feeding our signal into the grid. And what happens is it goes out the plate right here and goes into the grid of the 6v6. Now remember what I said, when it goes out the plate, it inverts the signal. So if I have this signal going into the grid, coming out of the plate in here, I'm going to have the opposite. It's going to be like this. Similarly, when I come out the cathode and go over to this tube, when I said it goes out the cathode, it comes out true. So when I come out the cathode, my signal is going to look just the way it came in, like this. So I have an opposite signal from here and here. That's the way a phase inverter works. That's the really simple way to do it. All right? That's really what it means. There is, I guess, a disadvantage to having an inverter tube in an amp, though. It doesn't create any gain. As a matter of fact, you probably lose just a little bit So there's no gain stage here. It's basically just going to, pass the signal through and split it through plate and cathode and give you the opposite push-pull. Basically, that's what happens. So that's a really, really simple explanation. Uncle Doug, if you know Uncle Doug, he's a really, really good teacher, basically. He's got a video that goes on for like 30 minutes about how this works, and I've probably not done it any justice. But that's why having an inverter tube really works well, because it allows you to take your signal and put it essentially out of phase. Without the inverter tube, your signals are in phase with each other. That's the right way to look at it. When you do it this way, out of phase. So again, check out Uncle Doug if you'd like. And let's take a look at our schematic here. And you'll see, here's our inverter tube. So the top, coming out of the plate, we go through a coupling capacitor into the grid of the first 6V6, and that would be our signal. But we also come out of the cathode, and we come here through another coupling cap down here to our second output tube into the grid. So remember what I said. This top one is going to invert it because it comes out the plate. When it comes in here through the grid, through the cathode, it's not going to invert it. So that's how we get our signals to line up. All right. I hope that's helpful. We will see you in the next episode, which will be the one when we put the tone pots in, and then we'll do our first test on the oscilloscope and see what it looks like. Hope this is helpful for everybody. Thanks for watching, and we'll see you guys soon, and happy Mother's Day to everybody out there.